Back to my YouTube channel once more. We have given a nice question here. Is example 4. This is an engine coupled via a single plate lash, right? So question 4 says, so what about this? An engine is coupled via a single plate lash. Okay, as you can see, single plate lash, we've been number of contact would be 2 always when we're dealing with a single plate lash. So we know the single plate lash, no problem, to a shaft. Fine. So now there's a shaft over here, which is fine. The plate has a contact surface at both sides, no problem. The outer and the inner diameter of the plate are the outer one and the inner diameter respectively. The coefficient of friction is this 0.3, and the force applied to the plates is, we've given axial force there, 2 kilonewton. The engine develops a constant torque. Here's our constant torque, and the moment of inertia is 2.3 kg per cubic squared. The moment of inertia of the driven shaft is given the of the driven shaft there, right? That was for the engine, because from the statement of the this of the shaft is 9, and excite the constant resisting torque here, friction torque here, resisting, this is simply friction torque as uniform wear. Okay, this will be uniform, we're under uniform wear theory, right? So you can see then when the clutch is engaged, an engine speed, here we have an engine speed 500 s per minute, the shaft is actively, no problem. Let us check now. A says, A there, they calculate here the combined speed between the engine and the shaft at the moment no slip occurs. Take a note, I've talking about this thing of no slip and whatnot. I explain it on my previous video when that is written flywheel and an engine shaft, right? So no problem. For all, you must know, since you've given this an engine, if you are given an engine and a single plate lash, what must come up in your mind, right? If you're given, or they say if you hear something talks about flywheel or an engine, what must come on your mind? You must know that torque retardation, you can calculate torque retardation if you want. Okay, we call it, I can say calculate step 1. I've talked about this, the retardation torque. If you want retardation, I just write retardation torque. But it's for what? Engine. We'll start by engine retardation torque. So which is, I will denote it by TRE. So retardation torque here, retardation torque of an engine. E represent engine, or let me write engine. Are you cool with this? R stand for retardation torque. Retardation torque, I said retardation torque is equal to torque developed minus torque, the constant one, constant torque, whereby I said torque developed, I said is the same, exactly is equal to the torque of a clutch, of that single clutch, the one that is coupled to single clutch plate, single plate clutch. I said is equal to this, equal. So that means if I have this, it's a one will be one is same thing. So I can simply replace that developed, but you must know is a torque developed. right? So you understand, right? So this is what we have there. So we have torque developed. What is torque developed? Torque developed, no, developed, it's equal to, remember, is the torque of the clash. We know that is always coefficient of friction multiplied by axial force multiplied by the number of darts contact. Coefficient of friction were given that it was 0,3 multiply axial. The force, I remember it was 2 something here. Coefficient of friction axial 2 kilonewton. I remember that is 2 kilonewton times 10. Now the problem here, R, we must calculate it. We must calculate R, which is, they said it was what, where, here it's where. We'll use this formula, isn't it? So if you know this formula, okay, let me just calculate it here aside. Where by R will be 0,175 plus 0,09 divided by 2, where here we're given the outer diameter, which is 350, we simply equal to 0,35. You divide this by 2, you get the radius. Then here we have 1/8, which you in meter will be 0,18. You divide this by 2, then you'll get your R, the small letter R, which is this. So when you do your things, if I punch that alone, for argument's sake, if I can say 0,175 plus 0,09 divided by 2, this is simply this is what 0,1325, which is made. So yeah, this is what we'll have so far. Now we can multiply this here. Torque developed 0,1325 multiplied by 2, number of contact. This will simply equals to 159 Newton meter. This is torque developed. Now we know that the torque of an engine, we use the formula. I said the torque of an engine, the torque retardation of an engine, retardation torque of an engine is equal to torque developed minus torque constant. Then constant developed is what is the same. I said this is the same of what, of the developed, the same as a clash torque, right? This is the same as of the same as a clash single plate clash torque of that clash, that any clash that will be given. So here we'll replace this with 159 minus constant torque. Let's check. Want you to check anything that you want to check. Let us scan for torque. Then this is the engine develops a constant torque of 45, constant torque there. As you can see, even you can see there, develops a constant torque of 45. So yeah, 45, subtract this by 45, we'll have that torque of retardation of an engine will be equals to what? If you subtract that, it will be 1 4 no 114 Newton meter, right? So we have this, but we know torque of an engine, torque retardation engine must be called, we use the standard form of the formula that we know of an engine multiplied by the angular of an engine. So when the angular will be torque of an engine over moment of inertia of an engine. The torque of an engine we know is the one we've calculated it, which is 159 over the moment of inertia. We should check it from here. Remember, of the engine moment of inertia, so must be careful. It then says the engine. What is important, the engine develops the torque, the constant torque of this, and the moment of inertia of, here is the moment of inertia, 2.3. Divide this by 2.3. This will be what will simply equals to punch this. This torque, one, no, sorry about this. Let me check. Here we got this, isn't it? Here, sorry about that. It is 114. It's 114 over the moment of inertia is 2.3. Whereby if we punch this 114 divided by 2.3, which is will be 49.57 measured in rads per second squared. Remember, angular acceleration from your, and for angular motion, even flywheels N5, either way, we are done with this one. Right, we've calculated that. So they wanted what here? But the combined speed. Oh, we have a lot to do. Remember, combined speed is equal to angular of the shaft multiplied by the engine speed, engine, not shaft, engine speed multiplied by angular of the engine plus the angular of the shaft. So we still have to calculate the angular of the shaft. As you can see, we still have to calculate that. We're limited by angle of the shaft. To find that angle of the shaft, remember retardation of the shaft. Now we can say, to calculate, let's just say the retardation. Now the retardation torque, now we're focusing on the shaft. You can say TRS like this. So TRS is the shaft one, right? So is equal to torque developed minus friction torque or resistance. Friction and resistance is one and the same thing. So this is what we have. Now the torque developed, we have calculated it here. It says the one here is the torque developed. So the same of the clash, right? Torque developed will be 159 minus friction torque, where it's our friction torque is the one of the resistance torque or friction torque. Then, and the moment of inertia of the driven shaft, you can see this is a driven shaft. We're talking about shaft there. Hopefully you see your thing here. They've given us shaft shaft, you have its, that is shaft, and excite a constant resisting torque of 10. That is the resisting torque. Resisting is just a resistance, which is the friction, which is 10. Subtract this thing by 10 here. By 10, then T of the shaft. Must get that would be, we are subtracting the 149 Newton meter, right? We have got this, but we know that our formula, our standard formula of the torque, moment of inertia of the shaft, multiplied by angular of the shaft, angular acceleration. Then want the angular acceleration of the shaft, you will have T of the shaft multiplied by moment of inertia of the shaft. The torque there was 149, as you've got there. The shaft over the moment inertia of the shaft, here it is. We've just shown that, which it was 9. See, the driven shaft, the moment inertia of the driven shaft is 9. So divide this by 9, supposed to get that. If you punch this 149 divided by 9, how cool it is, this will be 16,56 meters in radians per second squared. Remember the angular, do not forget that. So we have it. Now we have everything now in our formula. We have this, we are fine. We have that, we are given. Of the engine we have now, we can calculate the combined speed. Combined speed, no, angular of the shaft, the speed of the engine we're given, angular of the engine. Here we don't plus on the top. Remember, it's always positive, it's always a multiplication multiplied by the radians of the engine. Engine plus the speed plus the angle of what, of the shaft, right? So let me just write, let me not waste even space. I can just write it even here. I can say equal, let me, this of the shaft, we have calculated it, here it is, right? 16,56, right? So we have that multiplied the one of the radians, the speed of an engine, n of an engine is this. We've given, but now it's in rest per minute. Oh, it's in rest per minute. You say divide by 60. Let me say 500 divided by 60. What do you get? You'll get 8.333. Yeah, rest per 8.3333 over the same of the angular of an engine. We calculated it here on top, if you remember, is this one. It was 49,57 plus this one. Obvious, this is the one in the same thing, so you can check. So we punch this, you find the combined speed. Find the combined speed. Combined speed, it is 2,08 watt 6 reps per seconds. If you want this in reps per minute, you multiply by 60. You know your thing there. When you multiply by 60, we'll simply just say 2,086 times 60. Simply 125,16 rest per min. Or you can round it to whole number if you want. You can round it to the whole number. If you round it to the whole number, I don't know. But it's like this. Let's say you want it to round it to the whole number. So if you want it to the whole number, it simply equals to 125 rest per min. It's up to you. But it's one and the same thing. So we have that now. We are fine. Let's check B. What do they want? B says the total time of sleep. Remember that there was no sleep occur, but the total time of sleep there. You must know. Will always time will be angle of the shaft. We'll be dealing with the shaft. Now, angular acceleration. Now we know from your angular is 2 pi n from our previous part. This n note is just n, is not the n of nothing. It's a combined speed, is just n. It's not n for shaft. I did not write shaft. I did not wrote engine. It's just n. It's like this formula, it's n. That means that n will be a combined one. 2 pi n. Remember, combine, as you can see, there's nothing here. There's no s. It's not for the shaft. It's not for an engine. It's just a combine. Simply just n as it is. So I have n as it is here. You see n. So I can use this one, the one that it's in right per seconds, obviously. I'll use the one which is in right per seconds. So we know that is equal to that 2 pi n. So yeah, we can apply that formula here. We have 2 pi, then what is n? Combined speed, which is 2,086 divide by angle of the what? Shaft. Where is the shaft? Here I can take it from here before going to so far. 16,56. Then if I punch this, supposed to get this time to be 0,8 seconds. Shame. This time is so, it's another thing there. Hopeful. If you have punched that, what did you got? That is what I've got there. Yeah, just run it to, maybe someone will say 0,781 seconds, which is still fine. I decided to run it to first decimal there. Then we have C now. C wants us to calculate what the time taken for the shaft to reach, the time taken to reach that. Time taken. This area is here, and then you travel, you reach there. We want the time that happens there, and then there were sleeps there. Okay, since if there were sleeps, I can say calculate time taken to reach that. Can calculate. Okay, let's calculate the time after sleep age. You can calculate our angle after sleep age. Sleep. Okay, let me just say, but the sleep age. So we know that torque everyone know that the formula of the torque is equals to I multiplied by angular, right? So we come here now, we do our gymnastics things here. We must do the gymnastics, but yeah, let me just do like this. After slippage, you must know that. Okay, let us calculate the torque after slippage. First, I want to say calculate torque after slippage, after slip. So torque after slip, torque slip will simply equals to torque constant minus torque of the friction. Always is like this, always. This is the formula. So torque constant is 45. We know friction, we know is 10. We did that. We have no doubt about that, isn't it? So this will be 35 Newton meter. So which this is the torque slip, torque after. Ish. Okay, let me, because maybe someone will be confused if I say torque slip. Let me just say torque after slip, torque after slip of slippage. You have that torque after slip. So we know that torque after slip will be equal to moment of inertia after slip multiplied by angular after slip. But after slip, when you're talking about after slip, it's a combination. You must know that it's a combination of the engine moment of inertia plus the ng of the shaft. It's a combination, but must know it's a combination. What we have there, we will have the combination. Let's see now what the angular after slip f, let me just say like that, after slip will be I, will be what, torque after slip. I'll just say AF to represent is a torque after slip, then divide by moment of inertia after slip, like that. Then the torque we found here, it is after slip is 35, but I said this is the combination. After slip must be the combination what you've started with from the start until there, but going backwards with what, from with there for the engines, the moment of inertia, the boat, we combine this moment of inertias. We have 2,3 and 9. We'll just say 2,3 plus 9 here. Always after slip will be combination 2 plus 9,2, 9 plus 2,3 must be combination. So that will have 3 by my wife punched that. I got this to be 3,097 rats per second squared. That's what I have there. Wanting the time after that, we've got that, but now we want the time. Okay, the time I said is like, if you have a point, you have the time here, and the time here you'll have initial time and the final time. So I can say T1. This is simply equals to angular. It's an angular over that. That is what we have there. But this formula, you must know that, here. But here at this time after sleep, this W supposed to be 2 pi, right? We have 2 pi n, isn't it? But do not forget the n. Not forget the n. That n is the n for combined speed. But so this is simply the change. Why is like this? This must be simply change. Yeah, this must be change in that thing, because the average, if I travel, if the rotation, the point, if I want the angular between these 2 points A and B, must be a change. So that's simply a change. And then if this is the change in angular velocity, simply this will be 2 pi n, right? But we include in that the final of the initial, so this will be 2 pi, just I can say n of the engine minus 2 pi n of the combined. But if you take out the common factor, 2 pi is the same, we'll have n, right, of the engine minus combined speed. So this is the formula you're supposed to know again. So there on the top we'll have this to be 2 pi n of the engine minus n, like that. But now we have over the angular, right, over the angular. This angular must be after slippage. Then the angular after slippage, we know that angle, obviously we have calculated it. So here is 3,097. It's like this. However, here angular after slip. However, if one of these two, it has revs per minute, to convert one of the two, we're supposed to multiply this by 6. If we have this, if the speed, one of these two, if the speed is measured in that, we will multiply by 6, will divide by 6. But if it's in seconds, if it reads per in seconds, here will cancel, this will be like that. So this is the formula you're supposed to know here. If there's no that, let's check what is the speed there of the engine first before we conclude. Engine speed 50 rests per minute. So since it's rests per minute, if you want to use it as rests per minute, or you want to use it convected, you must not use that 6. But because if I want to substitute it directly, that 500, I'll multiply here, there must be 6 to convert that to rests per seconds. Hopefully you understood this, guys. So this is what we have now, the important thing here. So it's 2 pi of the engine, we know that was 500, minus the one of the combined speed, 30,97, 3,097, over angular of the, this is the angle, is not the combined speed. Where was the combined speed? Here is the combined speed. As you can check, is 2,086, or let it be used there because I've used that in res per minute. I will use this also in res per minute. It's 125. Can use this because I've used this in res per min. I cannot use this in res per second. They must correspond. So I'll use this also in res per minute. 25 combined speed here. Then the angular of this after slippage is the one 3,097, 3,097, but we want to multiply by 60 because this stuff here, our stuff here, is in reps per minute. So yeah, guys, you see what you must have. Also keep in mind this is T1, so this simply equals to 12,68 seconds. If you punch that on your calculator, it's T1. But the time taken for the shaft to reach that time, total time, if one the total time now, 1t plus T1, or this is what you want. We want the time that we've been calculated, the sleep one, before when there was no slippage, and the one that has a sleep. Total time taken, total time for the slippage. Did we calculate? Here we have the time for the slippage here. Do you remember of this shaft? Was the shaft of slippage, but it was 0,8. So 0,8 plus the one we've calculated. So yeah, 13,5 seconds. 13,5 seconds. So this is what it is, guys. So thank you guys for your time. Please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Sharp.